That is good. All right. So here is, and this is the first part of today's notes. You'll notice what I have highlighted. Okay, I have some items highlighted. The aqua blue, these are the 10 that you need to know for AP Chem.
So does that mean I need to know
Oh, yeah. Yeah. The ones in green, these are the extra ones that are nice to know, and actually all the chemistry teachers here at Plainfield like that. And I'm not opposed to them, but what's nice with College Board is they always tell you what the buys are, the bicarbonate, bisulfate, biphosphate, all those fun things. And I don't think there is a biphosphate on here, but yeah, it does exist.
So memorize the ones in blue and green.
Yeah. These are the ones that I want you to know. And what's crazy is, and this is for what I'm talking about for this is the test. Okay, what's on that sheet is for the quizzes. This is what I will be using for the rest of the year, and what I'll be using next year.
Well, whatever's on the quiz is going to be the test.
Not necessarily. Yeah. There's a few others, like I think they have bromate, BrO3 with a -1, that's not on here, that is on the sheet. Also, I have iodate on here that's not on that sheet. So, but if you make your flashcards for this, because the Quizlet has the other ones, you're going to be in good shape. Okay. But for the most part, they're very, very similar. There's just a few exceptions. Now, here's the struggle for today, and I'll be perfectly honest with you on the struggle today, is most of you have never seen these polyatomics before, and so you're going to have to go home and make flashcards. And the best thing, or the highest recommendation I can give is, on one side of the flashcard, write phosphate. On the other, write PO4 with a -3. Just carry them around, look at them often, because on Wednesday, you'll have to know these. Now today, it's the struggle, because you're looking and you're having to go back and find it. Hopefully after a while, you're going to go, man, he uses acetate a lot. Okay, so, what'd you say, Hunter? I'm sorry. Make a Quizlet? You could make a Quizlet, yeah. Is that fun to make?
It's easier.
Is it?
Yeah, because then you can just use it on your phone and carry your phone around with you. Instead of like carrying flashcards. What if you drop them?
That's a good question. Yeah, I know. Also, you'll notice, and I'm not sure if some of you did this in ICP. Do you remember using the ites, the hypoites, and the eights, or the pers? Does that ring any bells for those of you who've done this before? Okay. This right here, make sure you know this information in the box. Now, what this is saying is, like, if I'm looking, let's look at sulfate, or I'm sorry, let's look at chlorate, which is up there. Here, I'll just scoot this down a little bit, because chlorate's a good one that I use a lot for this example. Chlorate is ClO3 with a -1 charge. Okay, it ends in what? ATE. Now, if it ends in ATE, it's generally one of the polyatomics that was given to you. However, I can take an oxygen away, or I can take 2 oxygens away, or I can add an oxygen. When I do that, or when nature does that, the charge remains the same. That's important. The charge will not change when you take away oxygens or add oxygens. However, the name will change and its chemical property will change. So if I look at chlorate, ClO3 with a -1 charge, and I take 1 oxygen away, it's no longer chlorate, it's chlorite. It ends in ITE. If I take 2 oxygens away, now I have not ClO3 with a -1 charge, but I have ClO with a -1 charge. And now it's hypochlorite. So I put the hypo and the ite in front. This actually has more application for Friday when we name acids. And then if I add an oxygen, that's the last box, if I add an oxygen to that, now I have not ClO3 with a -1, but I have ClO4 with a -1, and we call that perchlorate. The 8 stays in place, we just put the per in front. So, also memorize that too. So if you have your you have these polyatomics memorized, and you're like, whoa, ClO4, there's ClO3. Good, yeah, that's right. But we added 1 oxygen, so it's perchlorate. Okay. All right, the good news is the rules are still the same. We're still writing the metals before the non-metals. And what did I say yesterday about identifying a metal other than on the periodic table? What charge does it have? It's a positive charge. and nonmetals have a negative charge. And what you'll notice is the majority, actually all but one, are negative. This is our only positive polyatomic that I want you to know about. There are many. There are many, many more polyatomics that are not on this sheet, but these are the only ones that I want you to know. So for the most part, a lot of the polyatomics that we're working with are nonmetals. Don't forget the algebraic sum still must equal 0, so we still want to make sure the charges add up to equal 0. So what we learned yesterday still applies. I like this. I put this on here a couple years ago. That identifying, so like, okay, some students say that looks like nacho. Sodium acetate. When you look at it, if you have NaC2H3O2 and you're like, whoa, there's a lot of elements in this. Yeah, but identifying who the metal is really helpful in identifying who the nonmetal is. So once you identify the metal, and again, ammonium is our only polyatomic that acts like a metal because it has a positive 1 charge. Once you identify the metal, in other words, I like to box it in, whatever's left is my poly, if there's more than one element. If there's just one element left, then it's just like what we did on the second day, yesterday. Okay. So this is kind of a little bit of a help to identify who the non-metal is. Okay. You ready for some fun here?
Will this chapter be pretty easy compared to last chapter?
Say that again.
Will this test be pretty much?
This test I will give you, and it'll be set up halfway. So on one half of the test, you're going to have the names, you give me the formula. The other half of the test, I'll give you the formula, you give me the name. But it's over all those types. So it's going over non-metal with non-metal or molecular compounds, simple ionic, polyatomic, the stuff we're going to do tomorrow with Roman numerals, and then acids. So there's a lot of stuff.
It should be pretty easy though.
Oh yeah, if you know this stuff, it'll be super easy. Yeah.
You said earlier, this is not being able to test, so we're just going to explain.
Well, to be on, okay, so you're saying that the information that's on the Quizlets, they are on there, but we're going to have compounds. So it's not going to, after you do the Quizlets, those are just individuals, like name that metal, name that non-metal. I'm giving you compounds, so you're going to have to name both of them combined. So the thing I won't do on the test is like the Quizlet, because those are individuals, where here, these are compounds. So we are still using them, but I'm not going to just test you over what is NO3 with a negative 1 charge. You're going to tell me that NaNO3 is sodium nitrate. Okay. All right, so let's look at. See if I can get rid of that. Here we're going to write the formulas, and we're still writing the metals first. So calcium, what is the symbol for calcium? Ca. And you may have to scroll up to look at the polys until you have them memorized. And that's the biggest part of today's struggle is just making sure that you know what the polys are or recognizing them. And hydroxide is good. You started with O. Good. So OH. And it has what charge? Negative 1. What's the charge on calcium? It's in group 2A. Plus 2. Good. And we're still doing the same thing yesterday. Does that equal 0? No. So algebraic sum must equal 0, so we need to multiply this by 2. So if I just put a 2 there, is that okay? Good. So we have to, if I just put a 2 there, that only does it for the hydrogen. So what I need to do is wrap this. Okay. Anytime you need to represent more than one polyatomic, you need to wrap the entire thing in parentheses, then put the subscript on. Now, with hydroxide, it's going to be a little harder for you to remember that because you're going to say to yourself, well, that looks all right. But when you have something like acetate, when we have to have more than one, and you put a 2 behind the other 2, that makes it 22. So that one doesn't look so daunting. But here, if you need to show more than one polyatomic, wrap it in parentheses. Now, yesterday, did we use parentheses? No, because those were individual elements. So if it's an element all by itself, don't wrap it. Only polys. So if you have more than one element that combines to form a charge. Okay? All right, let's do the next one here. Calcium acetate. Well, we just did calcium, which is Ca. What's acetate? Oh, and I want to say this too on the quiz, on the Quizlet. They have acetate and ethanate. AP uses acetate. So if you see on the Quizlet where it says ethanate, I want you to use acetate. If you're going to take AP Chem, you need to know acetate. Say it again. Good. And it has a -1. Good. So acetate C2H3O1 or O2. And what's the charge on calcium? +2. Does that equal 0? Good. So if I put a 2 here, that just looks strange. So that should be a reminder, hopefully, to go, no. We need to wrap that. Okay. So anytime you need to represent more than one poly, put parentheses. So poly, parentheses, poly, parentheses, poly, parentheses. Just say that to yourself a few thousand times. All right, sodium phosphate. What is sodium? Na, and phosphate is? It's on the far right, third column, upper right. PO4 with what charge? What's negative what? 3, good. And sodium, group 1A. So what do we need to do there? So do I put parentheses around the sodium? Do not. Do what we did yesterday. So if you need to represent just a single element, we don't wrap it up. Good. Hydroxide and aluminum ions. Who's my metal here? Aluminum, because it has a positive charge. So we'll put aluminum here, and hydroxide is OH. We used it earlier. So it's a -1, and what's the charge on aluminum? +3, good. So what do we do there? Good. So we need to have a 3 there. So wrap it up. So Al, parentheses, OH, close parentheses, 3. For hydroxide, from the sheet. Oh, you're asking how did the poly come to that? Well, oxygen has a -2 charge, oxygen's a +1. But you don't need to know that. So just have the charge memorized for that. Yeah, you don't need to worry about how those charges originate. We'll do that later. I promise we'll do that, but we'll do that later. Today we're crawling. I didn't do ammonium phosphate yet, did I? Okay. So ammonium, what's ammonium? Not an element. So ammonium, that's our only positive ion. So we'll write that first. And phosphate, PO4. And what's the charge on ammonium? +1? And -3. Good. So what do we need to do there? Good. And wrap it up. Okay. There's ammonium phosphate. Yeah, I'm sorry. Okay, good question. So I have a +1 for the ammonium. Good. Okay. Yeah. No.
And the last one, why didn't for hydroxide, why didn't hydrogen come before oxygen?
Good question. Hydroxide historically has been written like this, primarily because we have hydrogen hydroxide, which makes what? Water. So when we talk about, and this is dealing with acids and bases, when a hydrogen breaks off, we're left with that, and and I think it's more historical than writing HHO, even though that is H2O. And what's more important, remember, in chemistry, we don't have any hose. All right.
It's still funny.
All right, potassium nitrate. So you You gotta be paying attention. So what's K? Good. And nitrate? NO3. Plus 1, minus 1, so good to go. What? What's the matter? Okay. All right, calcium ions and carbonate ions. Who's my metal? Calcium, so we'll write it first. And carbonate, it's in the middle column, near the top. Okay. So plus 2, minus 2. Okay. Now again, the biggest issue today is just memorizing those polys. It's not like memorizing the 52 elements. This is a little more fun, let's say.
I don't think fun is the right word.
You're right. It should be fun. No, we're not done. Who just said that? Cameron.
No, because the chart is, I have all the highlights up there.
Oh, you probably did something or hit return.
Yeah, so now it all highlights.
Can you undo or are you typing things?
No.
It usually does that when you.
Sheet road. Yes, I just need to go.
I can adjust it for you.
I just have to highlight everything.
No, don't. I'll show you something. All right. So now we're going from first we did the name to the formula. Now we're going from the formula to the name. So here again, recognizing what sodium. This
I'm
one?
looking at the practice problem.
Oh, my bad. I'm looking here at the example. I was like, I think sodium. All right, Cameron, what is NH4? Cheater. See, all the things been moved, so now it's a
Yeah,
trouble.
I won't know. Wait, NH4?
Uh-huh.
I don't know.
Ammonium, good. And you know SO4. No, we don't have sulfur oxide. Sulfate.
Okay.
Now, do I need to do anything to that? Nope, we're done. Okay. Now, again, the reason why there's a 2 there is because sulfate has a -2 charge, ammonium has a +1. But I love you, and I already bounced it for you. Yeah.
So, the 2 that's on the outside, we just go for that.
Ignore it because, again, -2 +1. Okay? All right, what is Na2O? Yeah, go ahead. I'm sorry, Julianne.
So you don't use it.
No. Nope. Again, just like yesterday with the ionic, the charges are the reason for the numbers. So ammonium sulfate, anybody that's in the know knows that's +1, that's -2. So we need 2 of those.
Am I in the know?
You're getting there. All right. So what is Na2O?
Sodium oxide.
That's what we did yesterday. See how I'm mixing it up there? That's right. Getting you guys comfortable or actually uncomfortable and catching you off guard there. That's the way I roll. All right. What is MgOH? Parentheses 2. Magnesium. It's not a hydrate. Hydrate's water. What is it? Hydroxide. Magnesium hydroxide. Okay. Again, remember the OH is the OH -1. That's hydroxide. What is Al parentheses NO3 close parentheses 3? Aluminum nitrate. Okay. So.
They said it.
And then the last one here, NH4 is ammonium, and the Cl is chloride. So we're still, if it's an element, a nonmetal, drop it and add IDE. Okay? So again, the struggle is real. So be memorizing or making flashcards or Quizlets to learn these. Okay? Bless you. What is that? Well, there you go. I like that.
Yeah, I think I'm just gonna die.
Don't die.
No. I think I just
Yeah, Julianne. Explain what? Okay.
You just showed the orange box.
Oh. Yeah. So here, let me do this. Let's go back up here. Where was it? So you're looking at the orange box. Okay. So if I have ClO3 with a -1 charge, that is chlorate. Okay. If I take one oxygen away, I don't have chlorate. Let me do this. I don't have chlorate. I have chlorite.
But how do you know if it's a +1 or?
The charge doesn't change.
How
So-
are we supposed to do this before?
So if it has a 3, then it's 8, and if it has a 2, then it's 9.
Good. And if it
Give
has,
us the day to memorize.
and then if you have that, then you have hypo chlorite. Hang on, Cameron, don't go there. And then there's another way,
Wait, why would that be that? But it's
because I took 2 oxygens away. So when you take 2 oxygens away, it goes from 3 to 1.
Oh, but that's like the original one.
That's the original. That's the ATE ending is the original. So those are the primary. And then if you go ClO4 -1, we still have chlorate, except now we have per because we had 1 oxygen. So it all stems from this guy right here.
Can you leave that up there so I can write that down?
Yeah. Yeah, they're gonna curse you out.
Alright. Do I need to pass?
Oh yeah.
Do you think I can get a charger for the other thing?
It's not the charger. You have jacked that thing up.
No, there's 2 holes right there for charging.
I don't know. You can ask them.
Alright.